Okay, so now we talk about the rotating machine, right? And maybe this slide it includes the first machine that I will talk. This is a DC machine also, right? But today I think only rotating machine, right? Okay. Overview of rotating machine. And the rotating machine usually have two parts, and we use magnetic field to induce the force to another part, right? Or to induce the electricity to another part as well. Okay, so the station part we call stator is the non-moving part, and rotating part we call rotor usually. Okay, so motor, generator, DC motor, induction motor usually have two parts, stator part and rotor part. Okay, stator means non-moving, and rotor is the moving part, the rotating part. Okay, and usually the rotor is mounted on the bearing, right, in this side and in another side, right? We structure, we have the bearing here, we should have structure, we should have bearing here to support, right? Otherwise it cannot lift on the air, right? We support by the bearing, right? In mechanical term. Okay, yeah. And this is the motor in industrial, and this is the motor in the EV car also. The same structure, similar structure, right? That's motor and generator. Okay. So we have three types of machine. In basic classification, we have DC machine. It means DC generator. DC machine can be used in for both generator and motor. Right? DC gen and motor. And we have synchronous machine. Synchronous machine also have both generator and motor. Induction machine also generator and motor. Okay. So you don't need to remember this, okay? And maybe you use your understanding after study. So for AC machine, we have two types of machine, which is synchronous machine. What is synchronous machine? Okay, and we have some idea after I talk. And induction machine is here. We can use for both generator and motor. And for DC machine, we can use for both DC generator and motor, or we can categorize into series machine, DC series generator, DC series motor, DC shunt machine, and DC compound machine. Okay, this is DC compound machine. Okay, and for DC machine, right, is for example, we use. Where is the use of DC machine, right? DC motor are used in the when we have DC power supply, right? We use DC motor wherever we have DC power supply, right? Are available, for example, in the vehicle electrical system. Not in EV car. In EV car, we use induction machine. But in car electrical system, we have the battery, right? You know, we have the battery in the car, and we use the motor for to start the engine, for example, to start the engine, right? Car engine starter, like this starter. The starter is DC series motor. We also have battery charger. After the engine is start, we charge the battery back, right, by the engine. So we have DC generator here, right, to charge the battery also. So this is an example of DC motor. We can also have small DC motor, right, small DC motor used in many equipment, right? for small equipment. And for synchronous machine, right? Usually we use for large machine, large generator and large motor. For large motor, like this is generator, and most synchronous machine we use is as a generator, right? For large three-phase electric power generator are mostly synchronous generator driven by steam, gas turbine or hydro turbine. We have some force. To use it as the generator, we supply the mechanical power to those type of machine, right? And we generate the power, right? There are a number of large synchronous motor in industrial, but much less than induction motor. The mostly motor is induction motor. Okay. To use the synchronous machine, we need to supply the DC current to the rotor plus DC current. So it's required DC source here. And then we get three-phase power generation. Or if we supply the mechanical, if we supply three-phase, it will move. So to use synchronous motor, we need to supply AC power and DC power both to make it move. So it's not convenient. Okay, it's not convenient in practice. It needs DC supply to the rotor, the moving part, and we need to supply three-phase. So it's not widely used in motor type. But if we use it, if we move it, and we get three-phase power, it's easier to control the frequency into 50 Hertz. Easier to control. So the generator, mostly of the generator, AC generator is synchronous generator. Okay. And for induction machine, we can also use for both generator and motor. But most of induction machine we use it as induction motor. Okay, induction motor. So induction motor are most common driving device and share approximately 80% of motor in the industrial. So if you walk into the factory and you see the motor, you can guess that it's supposed to be induction motor. Okay, not synchronous, not DC, because it's mostly used for factory driving system. Okay. Induction generators are rarely found due to its difficulty in frequency and reactive power control. To use the induction machine as generator is not convenient. It's not convenient, right? But sometimes we use it. For example, for wind turbine generator, we use induction generator. Okay, in wind turbine generation system. Okay. And induction motor also used in EV driving system with some converter, some power converter. Okay. So in EV system, we also use motor, which is induction motor, and the battery will drive by converter. That I think you will learn after midterm, right? It will transform DC to AC. Okay, we can change DC to AC by some device. We call this type of power electronic device. Power electronic device. Okay, and the motor will go to can move, right? This is induction motor. It's the AC motor, not DC. But we use some driving system, right, to change DC to AC, and we can control the speed of the motor. Okay, we control the speed of the motor. So in EV car nowadays we use induction motor. Okay. And also we have some type of motor called servo motor. Servo motor are the motor that driving by power tie. We put the power tie, and this type of motor can very accurate to control its position. Okay, to control the position of motor. Okay, we need some this type controller to drive the motor. We call servo motor, right? The application of servo motor, for example, the valve, right? We can control the position of the valve to open the liquid flow, right? Very accurate, right? Or we can use in the robot arm, right? Robotic arm like this to control the position, right? Okay. And there is some special motor like traction motor. Traction motor is the motor to drive the railway in the railway system, right? Here. And it's driven by power electronic circuit. Okay, it's supply the electricity from the wire here, right? Overhead wire. Okay. So the performance characteristic of electric machine, right? We can calculate by the energy conversion and the efficiency. What we interest in when we consider the use of this type of machine. So we interested in efficiency. And the efficiency, what is efficiency? Is the P output divided by P input multiply 100, right? For example, if I supply the power electrical to this motor 100 kilowatt, and I can get the output power of 90 kilowatt. What mean by efficiency? Its efficiency is 90%, right? The efficiency is 90%. And where is 10%? Where is 10 kilowatt? Is mean the loss, right? It's lost by 10 kilowatt. Okay, so efficiency is 90 by 100 by 100, right? Here. So the loss in machine is depending on the structure and the use. In contrast, if I would like to generate the electrical power and I supply mechanical power, right? I supply mechanical power in this generator. This is as a generator right now. If I supply the mechanical power 100 kilowatt, but I get electrical power 90 kilowatt, same, right? The loss is 10% also. So it depends on we use it as the motor or the generator, right? Motor or generator. Okay. So we interested in efficiency. So how to calculate electric power input? The power input is depending on what? P is square root 3 VI and cos theta, right? You remember this. This is P, this is Q, this is S, right? S is root 3 VI, right? In three-phase system. And P then you multiply with cos theta, right? S cos theta is P, right? This is power factor. And how to calculate mechanical power? Mechanical power, this is electrical power. Mechanical power, how to calculate? Is the torque into radian omega, right? Have you learned it in mechanics, right? This is in Newton meter, right? And what is this? Radian per second, right? You can get this in watt, right? Yeah. So you have to measure the velocity, right? The velocity, right? And you have to measure the torque, right? In order to know the output power, right? In order to know the output power, right? We need to know these 2 points. Okay. So this is the important term when we use the machine, right? Maybe we interested in its efficiency, like this. So the loss in the machine have many is come from many parts, right? For example, we lost in rotational loss, the loss in the magnetic circuit, and the copper loss, right? Winding loss, copper loss, and field copper loss, for example. Yeah. And if it act as the motor, it's similar, right? We have field copper loss and amateur circuit loss, right? And rotational loss, because from the structure of the machine. Right? So now come back to this table again. I think it's better, right? So for DC, right, winding, we supply the rotor. Usually we supply DC, and the stator also DC. Okay, synchronous, stator is DC, rotor is DC, right? Induction machine, we supply stator in AC, but rotor sometimes we don't need to supply, right? This is the convenience of the induction motor. Okay. I think this is some typical example of the motor efficiency. It's okay. It's not so serious about this. Okay. This is last year examination scope, right? Scope of examination last year. But this year, maybe you're interested in this, right? I think for this term maybe, right? What should be in your midterm, scope of midterm, that you may have some good time of during New Year, right? To read some books, right? And I think maybe I will make multiple choice for multiple choice.
Our midterm is 40%.
Yes.
Our midterm is 40%.
50%.
Only midterm.
Yeah. Midterm is 50%.
How about
Homework. Homework. I think homework I made it maybe at first I think it's 10%, but I think I will give it 15% for you. Which is certified for exam. Okay. It's good. Just do it. I think multiple choice maybe 15% maybe, right? And then for the calculation, right? Maybe I made it 30 creation, right? Maybe 30 creation for 15%. Let's see. Or maybe 50 creation or 15 creation. It depends. And I think we need to talk to have some knowledge on the basic circuit, right? Basic circuit. Sorry. Some calculation, right? Calculation on basic circuit. Then what we have learned, right? I cannot remember, right? Nodal and mesh analysis, right? Nodal and mesh. Nodal or mesh analysis, right? Should be like that. Okay, right? Basic circuit. Overall nodal and mesh analysis. Superposition and Thevenin AC circuit. Superposition is there. And Thevenin Norton, right? then AC circuit, right? T-phase, right? AC circuit. Then we learn about magnetic circuit. And transformer, right? Only ideal transformer. Right? Only ideal transformer. Only basic one. And then rotating machine, right? Okay. Not very detailed on this. Rotating machine, I'm not sure, maybe DC machine and induction machine. Oh, too many. 1, 2, 3, 4, 5, 6, 7. Right? 7. Oh, too many. How to choose that? Maybe I make exam 7 and you can choose for how many? 20%, right? Choose for 4. Okay. Too many, right? So maybe we don't need to prove about basic circuit, right? No, basic circuit, no. Okay. Which one else? Node mesh. AC magnetic. Now we have 6, right? Okay. Okay. Anyway, within these 6 topics, okay, for 20%, and I will make multiple choice for you, 15%, like that. It should be very clear. And now we have 2 topics left, right? DC machine and induction machine, right? For after New Year, because next week we have no class at all. So DC machine, induction machine. You can see the video record of last semester, right? For DC machine, induction machine. Because it's very close to examination period, you may have no time to remind, right? You can study in advance, right? From video. We meet again on